I'm going to record my iPad and record the face-to-face thing. I'm not recording the Zoom, so that's kind of weird. So if I look this direction a lot, sorry, that's where my computer's at. I'm trying to see the chat and see what everyone needs. And if you have a question and stuff, just don't forget to unmute yourself if the space bar thing isn't working. Maybe you have to turn it on in settings. I don't know. All right. Now, the goal today is to do about 3 examples. The second example is the one that on the Google Classroom you have to submit the answer to me. What is the second derivative of the second problem? That's the new thing we're getting today. So we're going to learn how to do second derivatives today. Now, if you're not familiar with the derivative, I know like Ryan, this is his first time being back in a while. So congrats, welcome back. So let's talk about what we're discussing here. We're finding slope, right? Average rate of change. But what derivatives are is an instantaneous rate of change. It's so if you're on a curve, and we're looking at one specific moment on the curve, we're going to find the slope at that exact moment, whatever that tilt of that line is, where it doesn't touch the line again. That's what a tangent line is. That's an instantaneous rate of change. If it were to touch the line twice at a certain point, let's say I was doing here, and you were to draw the line like this, that's an average rate of change, and that's called a secant line. A secant line hits a curve twice, as you can see. We want the tangent line. So what we've learned yesterday, or what I introduced for the first time yesterday, was this idea that we have shortcuts for finding slope. The shortcut is called the power rule. It works for polynomials. It's pretty clever the way that it works. It's one of those things that I just want you to see how you do it. So the homework will ask, there's 5 questions in the homework. So I think you already got a Google question from me that says find the second derivative on the second example that we're going to do. But the homework will be a worksheet today, and it's 5 problems, and you're finding that first derivative. So you're doing the power rule. So it's 5 questions. One of the questions out of your 5, you're going to have to do the old school method of doing the differential quotient. You have to pick one out of the 5. I don't care which 5 you pick, which one, but you have to do the old school differential quotient and prove that's the answer, the one when you did the power rule. So I'm going to do those for you right now. So I'm going to kind of pick an easy example. We'll do a quick example of it, how to do it with the differential quotient, and then we'll go into some more challenging examples. Are we ready to go? Does everyone have their notes ready?
Brody, stop making noise. You keep showing up on my screen instead of a 1.
Yeah, it's kind of funny though.
So, yeah, you pretty much have to mute your camera, because if you're not muted, it'll take over.
Yeah, Brody.
All right. So. Okay, I think we're almost all present here. Okay, we got Braden now. Okay, all right. So again, thanks for being here. I know this is kind of tough. It's time out of your day, and it's 8th period, but we're gonna do this every day, even if you're in class or not. Homework will be submitted back to me via Google Classroom, just because if we go to a long-term distant learning, I want you getting used to that. So you'll submit all of your homework, that worksheet that you're going to do on a separate sheet of paper. Just do your work, take a picture of it, and then submit it back to me on Google Classroom. Just get used to that. We're going to do that from now on. It will eliminate the paper trail that I have in my room, and it will make it easier on you guys. You just know where to go submit it, and you don't have to walk to my room to do it. All right, let's go through the first example. This is the first one, not the second one, but the first example. So example is, let's go with 3x squared plus 4x minus 1. Okay, now we're gonna talk about the old method of doing it, the differential quotient, how to find slope, and then we're gonna do it by the power rule, which is the rule we just learned yesterday. So if you were absent yesterday, we learned a new method of finding slope, like very, very quickly. Some of you kind of figured out before, but I just want to make sure you know it. Now I don't care if out in front of this function, if you have like equals f of x, that's just the name of the function. I don't really care if that's there. It's just the example. Okay, let's talk about the shortcut first. Let's do that. So this is how you find slope. You drop the power out front first. That's what you do. And then what you do is you subtract 1 off the power. That's how you do it every single time. It's called the power rule. You drop the power up front, it gets multiplied on, and then you subtract 1 off the power. And you keep doing that as you go down the row. So in the next one, the 4, Well, there's a 1 on the x, so you have to drop it out front and multiply it on the front, and then subtract 1 off the power. And then for the back number, well, it was x to the 0, so you have to drop the 0 out front. So you take 0 times 1 and x, 0 minus 1. So this just turns out to be 0. So any constants in the back will always make 0. They just kind of drop out. Now, what's going to be in the front? What is my first root here, or my first term in this polynomial? What does this turn into? What is?
6.
Yeah.
No, that was rude.
Yep, 6x to the first. And then the next one,
Plus 4.
plus 4, yeah. Because this would be x to the 0, right? 1 minus 1 is 0, so that would just be a 4. Any term that's to the 0 power just kind of goes away. It turns into a 1. So this is the answer. This is what I'm looking for. That's the slope for this function at any moment. So why this is important is, and again, we'd call this f prime of x or y prime, whatever you want to call it, right? It's the slope. It's m. So at any moment on this curve, it's actually a parabola, I can find the slope by just plugging in any number I want, and it will tell me the instant slope at that exact moment. Okay, I'm going to take a picture of that. Now, I'm going to do the same problem now, but I'm going to do it the old method, the differential quotient, because at least one of your problems on your worksheet today, you have to do it by the old method to prove that was the answer. So you have to show both forms, just one of them out of the 5. Okay, so this was what? 3x squared plus 4x plus, what was the other number? Was it plus 7? No, minus 1. All right, minus 1. Minus 1. All right, so, okay, so doing this by the differential quotient. If you don't remember that formula, this is what we did. It's f of x plus h minus f of x all divided by h. And eventually at the very end we'll plug in zeros for h's, and then you can stop there. You don't have to plug in, you don't have to set it equal to 0 in factor. You don't have to do any of that. So we're gonna set this formula. So okay, so first of all, taking my function and plugging in x plus h into everything. So 3x plus h squared plus 4x plus h minus 1. That is just this part right here. It's with x plus h plugged in. Then I still have to subtract the original function. So I'm still going to subtract the original function in the back. The original function is this 3x squared plus 4x minus 1. And this is all divided by h. All right, questions up to this point? I think we've done enough of these. You probably know them forward and backwards. Okay, now why I picked this problem is because it's got that 3 out front. We never really dealt with any of these too much, where there's a leading coefficient, that 3x squared. You have to actually FOIL this part out first. You have to do this part first. So this is x plus h times x plus h. And then whatever that answer is, then we'll take it times 3 last. That really gets people. So this turns out to be x squared plus xh plus xh plus h squared. If I were to FOIL first, outer, inner, last, that's just this part. And then I'll multiply the 3 through it. Again, you can shorten that up. Some people already figured that out. We've done enough of these. You probably already have it kind of memorized. Now for the back, I'm going to distribute the 4 to everything back here. So this turns out to be 4x. Why can't I draw that plus sign? Give me that plus sign back. Oh, there we go. 4x plus 4h. Oh, that was a terrible h. 4h. And then we have the minus 1. And then we're going to distribute this negative sign back here to all these parts. So that's negative 3x squared minus 4x plus 1. All over h. Okay, so now we're going to distribute that. We're going to distribute that 3 through, so we have 3x squared plus 3xh plus 3xh plus 3h squared plus 4x plus 4h. Wow, why do I keep doing that? 4h minus 1 minus 3x squared minus 4x plus 1 all over h. I take the JNBOE6. Is that Erica? Erica, is that you? I can get you down for attendance.
How do we know what we're labeled?
It usually has your name, but for some random reason, like certain people don't have a label on their name. Oh, it's Garrett. Oh, hey. Or Garrett. I just called you Garrett. I'm so sorry, Wyatt. All right.
That's his school name.
Yeah, it's weird. Why isn't?
You know that 6.
Huh. All right. Okay. Okay. Anyway, let's keep going. All right. So, all right. We got to this point. We've distributed. Now, the idea is that I'm going to start crossing things out. So, things that don't have h's should cancel out. So, like the 3x squares are gone, the 1s are gone, the 4x's are gone, and everything that's left should have an h on it, which it does. And then you're going to divide everything by 1h. So this should be the simplified answer. It should turn out to be 3x plus 3x plus 3h and then plus 4. That's dividing everything by an h on the top row. And then your last step is to plug in zeros for all of your h's. So your final answer, the final slope that we should be getting should be 6x plus 4. That should be the final slope that we should be getting, for any point on this curve. And that proves what we just did a little bit ago. If you go back, this is the same problem that was the last one, right? If you go back and check, it's the exact same problem. It's still 6x plus 4. There's just, the power rule is so much easier. It's just as much, it's just this quick way of figuring out slope at any point. Okay.
Ward, why don't you set it to equal to 0?
It's not asking you to find where the max and min is on this problem. It just wants to know the generic formula for slope. Okay.
Gotcha.
All right. So let's work with the next one here. Okay. So this is the second example. This is the one that I want you to write down. This is the one that for the Google form question. The Google form question says, what is the second derivative for the second example, the second problem we're doing? This is it. So I'm just going to create a problem. So let's say this is g of x is equal to 4x cubed plus 12x squared minus 5x plus 10.
Wait, what method do you want us to use?
Say it again.
What method do you want us to use?
We're going to use power rule. We're going to use the power rule only. Because the last example, I just wanted to show you that you get the same answer if you did the differential quotient. Now we're going to just use power rule. That's the whole point of this worksheet, is just to get practice using power rule the whole time. That's that shortcut where you drop the power out front. The easy way of doing it. So the question on the Google form thing says you have to find the second derivative. That means you're going to do the derivative once, the power rule, and then after you're done, you're going to do it again. So you're just going to complete the same steps. So let's go through it for the first time. So g prime of x, we're finding the first derivative. Power rule. So that's where you drop the power out front, you multiply it, and you subtract 1 off the power. You drop the power out front, and you subtract 1 off the power. You drop the power out front, and you subtract 1 off the power. Subtract 1 off the power. And then for any constants in the back, just put 0, because you're going to drop the 0 out front. 0 times 10 is 0. Because this
So
would
our
be...
answer is going to be 0.
4x.
No? We'll get to the answer here in a minute. We're not done yet. It will not be 0.
And the second derivative, you have to do it again.
You have to do it again, but you still have numbers and variables still.
Yeah, but you have 24 times 0.
No.
Okay, work it out.
24.
Let's keep finishing here. I'm still doing the first derivative. We'll get to your question here in a minute there, Isaac. Okay. All right. So doing this first derivative, we get 12x to the second plus 24x minus 5, and the x to the 0 just kind of goes away. So that's the first derivative. This is g prime of x. That's the first derivative. That's slope. Now they want us to do the second derivative. That means whatever this answer is that we just came up with, you're going to do the power rule one more time on it.
Wait, Ward.
What's up?
So that's where we would stop for the homework, because it says find the first derivative.
Yeah, so on your homework, you're going to stop here on every problem.
And then it says using the differential quotient to prove your answer. So we have to do the other thing.
Only on one of them. On one problem, you have to do the differential quotient.
Do we ever have to like foil it all
doesn't say
out?
that.
On
Well,
power?
that's my directions. So,
Just pick one and do that.
yeah. So, sorry, Morgan, what was your question?
Do we ever have to foil it out on like big powers? Bigger
Um,
than 3?
if you had to do the differential quotient, yeah, you'd have to, but there is a easy one on there. You'd probably want to pick a certain problem on that worksheet. I have some big powers, and yes, you'd have to FOIL unless you pick one of the easier ones, because you get to pick which one you want to do the differential quotient on.
Oh, okay.
So you only have to do it on one. So if you didn't hear Jamie, that was her question earlier. I don't know if I put the direction in there. I thought I did. Maybe it was in the weird directions on Google Classroom. Maybe it says it. Okay, let's do the second derivative. So second derivative here, I'm going to finish this up. Second derivative, I'm just going to do the power rule. I'm not going to write all my steps. I'm just going to do the shortcut. So drop the power up front. So this will be 24x to the first. Drop the power up front. This will be 24 times 1 and then x to the 0. And there's your second derivative. This is the answer I'm looking for on your Google form. That's what you got to enter. So I know a lot of you have your cell phones. You can pop it up and type it in.
Wait, so why isn't it just 24?
Because you're still doing the power rule on this equation right here. So you still have to drop this out front, subtract 1.
Okay.
Does that make sense?
Yeah.
Yeah. So
I
it's...
just realized that 24x was the first one.
Yeah.
I thought it was explaining.
No. So, nope. All right. Okay, so again, your homework is just doing the first derivatives. Just doing the first one. So I'll do another example here in a second. I'll let you have time to write this down.
Why do we do it more than once?
Okay, great question. That's what I was hoping to hear. Why would you ever want to do a second derivative? Second derivative gives you velocity, or gives you acceleration on a problem. First derivative gives you rate of change, which is speed, velocity, but second derivative gives you acceleration. So, like, if you're going on a curve north of Garner and you're going past Quickstar, and you're going on that curve and it says the speed is 24 miles an hour, 25 miles an hour, that's the speed. They've also considered what your acceleration needs to be. Because if you're accelerating or deaccelerating, that also affects it. So second derivative of that curve would be acceleration, and they put that in consideration if you're speeding up on that curve or if you're slowing down on that curve. That could affect how fast you can take that curve. So by being around 24 miles an hour, you can still speed up around it and you'd still be fine. It would still hug you to the
I
curve.
feel like 45 would be fine.
I wouldn't say that far. All right. Now let's.
5 works, Isaac. I've done it.
So let's do one more example. Just something quick. I'm just going to show you the ease of it. So h of x, 15x to the fifth plus 4x to the third minus 25x. So if this is my function, your homework just says find the first derivative. Do the power rule. That's all I want you to do. On one of the 5 questions, You'll also have to do the differential quotient, just on one of them. I don't know if it did, obviously it didn't explain it on the worksheet, but I think maybe in the Google directions, I think I said it. On one of the problems, you'll do the differential quotient. I probably wouldn't do the differential quotient here if you listen to what Morgan asked earlier. Would I have to FOIL the differential quotient on a really big problem? Don't pick this one, because I'd have to use Pascal's triangle to FOIL this thing out. So first derivative, so h prime of x, I'm just going to do the power rule. Drop the power out front, subtract 1 off the power. Drop the power out front, subtract 1 off the power. Drop the power out front and subtract 1 off the power, and then just write down my final answer. So this is going to end up being 75x to the 4th, 12x squared, and 25, because the x to the 0 disappear. And that's what I want. I want that first derivative if you're using power rule. This is what I'm looking for in the worksheets. That's how quick I want you to see it. The worksheet should take you like no time at all. The only question that will take time is that one where you have to show the differential quotient. You just have to do it on one of them. Okay, questions on what you have to do today?
When's the homework due?
Friday. It's 5 questions. You can use the power rule on every single one, but on one of them you have to do the differential quotient as well. Submit your homework on the Google Classroom. Take a photo of your work, submit it on the Google Classroom. We're going to do that from now on, so you can get it turned in. So it eliminates my paper trail in case we have to do a long-term distance learning. You're already doing it every single day for me. Tomorrow in class, half of you will be here probably, so we'll go through some more notes. We'll probably review some of the stuff, and we're going to start the next type tomorrow, the next type of derivatives. Not second derivative, but something different. All right, that's it for today. If you want to log off and go work on your homework, you can. If you've got other things to work on, you can go do that now. Thanks for being here. I really appreciate it. I use this time for attendance, so if you can't be here, I mark you as absent. So try to log into the Zoom every day. So.
Ward, I got a question.
What do you got? Fire away.
But it's about an Apple Watch, not this.
Okay, that's fine. I'll stop the camera here in a second. Does anyone else have any homework-related questions? Okay.
Nope.
All right, I'm going to stop the camera and I'll stop that. I'll stop recording here and then you can ask away.